In this video, I'll be going over how to multiply matrices. So what are matrices? They're tables that can be organized by their rows and columns, and you can use the operations addition or subtraction or multiplication between them to form new matrices. So what does a matrix look like? It's, as you can see, this is an example of what a matrix would look like. We have columns, which are the vertical sets of numbers in a matrix table. And we have rows, which would be the horizontal sets of numbers. So A of 11, A of 12, A of 21, A of 22. These would be rows. Also, column would be A of 11 and A of 21, or A12 and A22. And so we would call this matrix, matrix A, a 2 by 2, as in 2 rows by 2 columns. So now that we're familiar with what a matrix looks like, we have some rules for when it comes to multiplying them. The first rule would be that in order to multiply two matrices, the first matrix must have the same number of columns as the second matrix has rows. So basically this means that if I wanted to multiply matrix A by matrix B, then matrix A, since it has two columns, matrix B has to have two rows. So in other words, if matrix B had 3 rows or 4 rows, then we couldn't multiply these together. The second rule, matrices are multiplied with each row of the first matrix by each column of the second matrix. So what this means is that we'd have to take the row of matrix A, A11 and A of 12, and multiply it by B of 11 and B of 21 to get the first element of matrix AB. We can't take the columns of matrix A and multiply it by matrix B's rows. Otherwise, we would end up with a different answer. The third rule. The dimensions of the product of two matrices can be found using the rows of the first matrix and the columns of the second matrix. So what that means is that we could take the fact that matrix A has 2 rows and matrix B has 2 columns, and use that to find out that matrix AB will have 2 rows and 2 columns as well. So now that we know the rules for matrix multiplication, let's go ahead and solve some examples. So for number 1, what is the product of matrix A times matrix B? So to start solving this, we'd first want to write out the dimensions of matrix A and B, which I've already done. And so we know matrix A is a 3 by 3, 3 rows by 3 columns, and matrix B is a 3 by 2, 3 rows by 2 columns. And so to find matrix AB, we know that we made matrix A's columns to be the equal amount to matrix B's rows. And as we can see here, we have 3 columns in matrix A and 3 rows in matrix B. So since they're the same number, that means we can indeed multiply these two together. And so now we want to find the dimensions of matrix A and B. And to do that, we'll take the 3 rows in matrix A and the 2 columns in matrix B. And so that's going to tell us that our final product, matrix AB, will be a 3 by 2. So now let's start the multiplication. So in order to multiply, we're going to take the rows of matrix A and multiply it by the columns of matrix B. And to do that, we'll take row A, 4 to 9, and just write that out. 4 plus 2 plus 9. And then to multiply, we'll take the column of matrix B. And so that's going to be 3, 1, and 5. So 4 times 3, 2 times 1, and 9 times 5. And so we would basically just multiply these together and then add it, and that would give us our first value for AB. Although before I do that, I'm going to solve for the second value in the first row of AB. And so to get that second value, we're going to take our first row again, 49, and this time we're going to multiply it by the second column of matrix B, 2, 7, 4. 2, 7, 4. Alright, so let's start solving this. So 4 times 3, that's going to give us 12. Plus 2 times 1, which is 2. Plus 9 times 5, that's going to give us 45. So 12 plus 2 is 14, and 14 plus 45 will be 59. And so that's going to give us our first value of 59 in the answer. And so for our first row, we have the value 59, and now we're going to solve for the second value in the first row. 4 times 2, that's 8, plus 7 times 2, which is 14. And then plus 9 times 4, that's going to give us 36. Alright, so adding this together, 14 plus 36 equals 450. 50 plus 8 equals 58. And that's our second value. And so this would complete the first row of our matrix. And after that, we'll want to solve for the second row of this matrix. And to do that, we'll take 5, 6, 3 and multiply it by the columns of B again. So 5 plus 6 plus 3. Oh, 3. And so we're going to multiply this by the first column of B. 5 times 3. 6 times 1. And 3 times 5. Alright, now we write out the second row again. Oh, 5 plus 6 plus 3. Right, and now we multiply by the second column. 2 times 2, 6 times 7, and 3 times 4. Alright, so now let's solve this. 5 times 3, that's 15. And 6 times 1 is 6. And 3 times 5 is 15. So 15 plus 15, that's 30. 30 plus 6, and that's 36. Next, 5 times 2, that's 10. And that's going to be plus 7 times 6, that's 42. And plus 3 times 4, that's 12. 42, there you go. So 10 plus 12, that's 22. 22 plus 42, that's 64. Alright, there's our second row. Now let's solve for the last row. Alright, let's write out 8 plus 1 plus 0. And then the first column of B, 3 times 1 and 0 times 5. Alright. And now for our third row again. 8 plus 1 plus 0. And now the second column of B. 8 times 2. 1 times 7. And 0 times 4. Alright, multiply this out. 8 times 3 is 24. Plus 1 times 1, that's 1. And then plus 0, because 0 times 5 is 0. Alright, 24 plus 1, that's 25. And finally, 8 times 2, that's 16. Plus 1 times 7, that's 7. And plus 0 times 4, 0. 16 plus 7, that's going to give us 23. And so that's going to give us our final answer for matrix AB right here. Alright, and so that's essentially how you would multiply two matrices together to find the product here. And so before I end this video, I'm going to go over the last example. What is the product of matrix B times matrix A? So as you can see, this is the same problem as number 1, but you can't solve. But even though it's the same problem, uh, you can't actually solve matrix number 2. Sorry, because as you can see, A is once again a 3 by 3, and B is a 3 by 2. However, since we're solving for BA instead of AB, and since B has 2 columns, A has to have 2 columns as well, or else you can't solve that. So this just shows that even if it's the same problem, and even if you could solve AB, that does not mean you can also solve BA the same way. You'll not only get a different answer, but for this one you just can't solve it at all, because there's a different number of columns for B than there is a number of rows for A. So basically, multiplying matrices, unlike real numbers, isn't commutative. Multiplying matrix A times matrix B isn't the same as multiplying matrix B by matrix A. And so with that said, that's about all for multiplying matrices.